Yeah, so I want to show you some like tricky kind of problems that we can work with here, right? Because apart from the straight up like integration questions or definite integral kind of questions, how can they sort of make these trickier? One thing they might do is start changing the things that they expect to get, right? So rather than just integrating, what you have here now is, okay, we have some expression, but now we have some initial conditions, right? What I mean by that is they give you some other information. So here they tell you that not only is the derivative e to the 7x, but they also have this, f of 0 is equal to 1. And we're asked to find f of x and hence find f of 1. So let's go back to this. What does this mean? Right, think about your function notation. This is saying f of x, right? So it's saying at an x value of 0, my y value is equal to 1. That's what's going on here, right? Because they're replacing the x with 0 here, and when you evaluate this, you get a y value. So I want to think about using that, because when I want to find f of x, right, it can't be in terms of with your constant. We actually have to find the actual expression which is used. That's what they're expecting here when they give you these other pieces of information. Yeah. So let's go ahead and try and find that. So for part A, right? So I've got that e to the 7x is my derivative. So if I want to integrate that, again, I use my same identity here. So my a value is 7, right? So I've got 1 over 7 e to the 7x plus your constant. But at this point, this is where I want to use the info I've got, because I actually want to find a value for c now. That's what this means, right? So let's go ahead and say, okay, since f of 0 is equal to 1, right? Because this is what f of x would be, but I don't have this constant value. So what I can say is, since f of 0 is equal to 1, I can say at x equals 0 for this, right? 1 over 7 e to the 7 times 0, right? So I'm replacing x with 0 now. That's what I'm doing when I'm writing this. So this would be my function plus the constant. What's that equal to? Well, that's actually equal to 1. Can you see that? Right? Because the reason why is this whole thing is f of x, whatever, including whatever the c value is, right? So this whole thing is equal to 1 when x is equal to 0. That's why I can create this equation here. And what that means is, well, think about what this is. Now remember, it's not going to be 0, right? Because this is going to be e to the power 0 when you multiply this out. And that's just 1. That's 1 over 7 plus c is equal to 1. Can you see that we're just solving an equation here now? Your c is going to be subtracting 1 over 7 from both sides. I'm just going to get 6 on 7. Okay? So, still need to answer the question, right? So, f of x is equal to 1 over 7 e to the 7x plus my constant. That's 6 over 7 there. Yeah. All right. So that's part A. Awesome. And naturally, once they get you to do that, they'd love to find part B as well, which is find f of 1. So f of 1, once you do that, all you have to do is substitute x equals to 1 into this part. So we're going to get 1 over 7 e to the 7 plus 6 on 7 there. All right. And I'm just going to leave it as exact. I haven't really specified, but yeah, that's finding f of 1. And this is an example of a different kind of question, right? So we're looking at using initial information that we've been given to find out these expressions and values. All right, so continuing on from that, like looking at problems where we've got derivatives and we want to find original expressions, this is an example of how we might do that, right? So they're asking us to find the derivative of e to the x squared. And so remember, this is kind of using your chain rule, right? If you've got a function wrapped around other functions, we have to take the derivative of this power, okay? So we have 2x is the derivative of the power. So I should say, I should write this properly here. So I should say d dx of x squared, e to the x squared. That's equal to 2x here, so the derivative of this part. And then we keep the original function the same, so it's e to the x squared, okay? And you can check by reversing that process, see that works out. That's your derivative. But see, this is different now. They asked you to use that because hence means you have to use the bit before. If they don't say otherwise, you actually have to. You don't have a choice here, right? So hopefully you can do that. Hence find the integral of this. And this is not a standard form that we have over here, right? Because it's actually two functions multiplied by each other. And unfortunately, we don't have the tools to do that. In extension 2, you do learn something called integration by parts, which is really cool. But right now, we don't. So I guess this is how they make problems harder. Problems that seem initially kind of impossible they can use previous parts to help you out, right? Because what you might notice is this looks very similar to this. What's the difference? Yeah, right, so there's a 2 here, but there's no 2 here. So you might want to think about how can I actually incorporate that into this? Because if I was just given this to integrate, I could do that pretty easily. All I'd have to do is write that. That would be my answer, right? Because remember, integration is the reverse process of differentiation, and I could just write that straight up. But if I've got this over here, it's not quite the same. It's very similar though. And some of you might be catching on to what I'm trying to lead to. And this is why it's so important you recognize this idea of undoing things when we're using the reverse chain rule, right? Because if I want to incorporate a 2 here, I could just write that, but I've changed the expression. So in order to undo that, I could just divide by 2. And a way that I can write division by 2 is multiply by half. Now I could write that right here, but because I'm going to take it out anyway as a constant, I'm just going to write it at the front. So can you see how the multiplication, the product of these two, will mean that I haven't changed the expression at all? But what it's allowed me to do is say, oh, I know the integral of this now, right? The integral of this is just going to be, now this half is outside, right? It's just going to be going back to this, right? That's what, can you see why they get you to do this previous part before you have to do the next one, right? Because really without it, you wouldn't be able to see that. So this is just going to be e to the x squared from -1 to 1. And when you evaluate, you actually get something really cool. You end up getting, well, that's just e to the 1 squared minus e to the -1 all squared. Well, that's just going to be e to the 1 minus e to the 1. That's just 0, right? So that's just going to be 0. Now, why does that happen? Well, think about what integrals represent. Remember, integrals represent areas under curves. And so if you actually sketch this function out, it turns out it's an odd function, and it looks kind of like a cubic almost. So it looks kind of like this from memory. And so if I'm going from -1 to 1, what do you think might happen with these areas? Yeah, that's right. These areas are going to kind of cancel out, right? So that's a situation where we have a derivative, and they're asking you to use that to find the integral of this guy here. And you can only do that once you get the previous part. Other types of questions they may ask, and again, it might not be so explicit, but like if I was to find the area under y is equal to e to the 3x from x equals to 0 to x equals to 5, for example, we can do that as well. Right, and they may actually ask you to find the exact area because we don't want to evaluate this. And again, like thinking about what integrals represent, they represent areas into curves. So if I was to sketch this out, it would look something like this. So from 0 to 5, so somewhere over here. And so you have to make the connection that area under curves and integration are a very closely related process, right? So all that's asking for is, okay, find the integral from 0 to 5 for this function here, right? And we can go ahead and do that. We've done that a few times now, so that's just going to be 1 over 3 e to the 3x from 0 to 5. And we can go ahead and evaluate. I'm going to end up with, again, I'll take that constant out. So I'm going to get e to the 3 times 5 here, so it's 15. E to the 3 times 0. Don't make the mistake of just writing that as 0, remember? So it'll be 1 over 3 e to the 15 minus 1. And because we're dealing with area here, right? Remember, you've got units squared as well. Okay? So these are, yeah, some kind of trickier problems we can work with integration. You just might have to do a bit more thinking or change your perspective on things slightly. Okay? Any questions about that?